Hello and welcome back. In the previous videos, we have discussed in depth about the architecture of HDFS and MapReduce. In this section of the videos, we will explain in detail how to set up Hadoop. For this video, it is essential that you have downloaded the required software. Primarily, we require a virtual machine which has Linux installed, along with VMware Player and PuTTY utility software, all of which are free downloads. So without much ado, let us start off. Before we move on to setting up Hadoop, it is really important for us to recall Hadoop's architecture. So let us quickly and briefly recall the architecture of Hadoop. What does running Hadoop actually mean? It means running a set of daemons or processes on different machines. The different processes are responsible for handling the two core components of Hadoop: HDFS, which serves the purpose of distributed storage, and MapReduce, which is responsible for the parallel processing framework. And these daemons have specific roles. Some exist only on one server, whereas some exist across multiple servers. There are three major categories of machine roles in a Hadoop deployment. We have the master nodes, slave nodes, and then we have the client machines. The master nodes have two key processes running. Name node. This oversees and coordinates the data storage function and stores lots of data. This is the HDFS. Then we have the job tracker, which oversees and coordinates the parallel processing of data using MapReduce. And we also have the slave nodes that make up the vast majority of machines and do all the dirty work of storing the data and running the computations. The slave nodes run two processes. Data node. This communicates with and receives instructions from its master, the name node. This is responsible for storing the data in HDFS. And we have the task tracker, which receives instructions from its master, which is the job tracker. This is responsible for running your business logic as a MapReduce program. And lastly, we have the client machines who have Hadoop installed on them and whose purpose is to load data into the cluster, submit MapReduce jobs, and retrieve its results. So essentially, we have many processes running in a Hadoop cluster. The name node, we have the secondary name node, data nodes, we have job tracker, and the task trackers. And there are three ways you can set up Hadoop based on where you run these processes. You have the local or the standalone mode, then you have the pseudo distributed mode or a single node Hadoop cluster, and finally we have a distributed mode or the multi-node Hadoop cluster. We will need to change certain configuration files to change the mode in which Hadoop is set up. In the case of distributed mode though, in addition to configuration file changes, we also need multiple machines as well. We will discuss this more as we get to that stage. So first, let us get down to setting up Hadoop. There are a couple of prerequisites for setting up Hadoop. Firstly, we have the operating system. Linux is the official development and production platform for Hadoop. A significant number of production clusters run on Red Hat Enterprise Linux or its freely available sister CentOS. Ubuntu and SUSE Enterprise Linux and Debian deployments also exist in production and work perfectly well. It is important to note that Apache Hadoop version 2.2 onwards also supports for running Hadoop on Windows as well. But in our class, we are going to use Ubuntu Linux. And the second prerequisite for running Hadoop is that it requires Java version 1.6 or higher. So what we're going to do is set up Hadoop on a virtual machine. So please download the VMware virtual machine which has Ubuntu Linux 12.04 installed on it. Hope you have already downloaded it. If not, the link to download this virtual machine is here and it is free. And please also note the usernames and passwords for the virtual machine. After you download, you should see a file called ubuntu1204.zip. Now you just have to unzip this file to a folder and remember the path. In the interest of time, I have already done this, but in general it will take a minute or so to unzip the files. Now here is my unzipped folder. In order to run this, you need to download and install VMware Player, which is also a free download. Go to the link below and download the appropriate version. Install the VMware Player just like how you would install any other Windows software. After you have installed VMware Player, to launch the Ubuntu virtual machine you have downloaded, first launch the VMware Player from the Start menu. I have already launched VMware Player. Click on Open a Virtual Machine and go to the folder where you unzip the Ubuntu virtual machine and select the VMX file and click on Open. Before you play the virtual machine, edit the virtual machine settings. Make sure you choose at least 2 GB of RAM, and also you have the option of changing the virtual machine name as well, and then click on OK. Now click on Play Virtual Machine. This will take a couple of minutes to load and also prompt you to choose if you want the virtual machine to be started every time you start the machine. So choose No for this. It might also prompt you for updates, so choose No for now. Now once the virtual machine is up and running, I can now launch a terminal inside the virtual machine and perform my Linux operations. Now let us run some basic Linux commands to check if it is working fine. Okay, so we have our virtual machine up and running. Next, we need to update the local installation packages with the latest updates from its sources. So to do this, type the following. It prompts for the password. So once the virtual machine is up and running, I can now launch a terminal inside the virtual machine and perform my Linux operations. So let me launch a terminal window. And let me run some basic Linux commands. Whoami tells me who the current user is. I can list the current directory, and I can print out the present working directory as well. So next, importantly, we need to update the local installation packages with the latest updates from its sources. So to do this, type the following command. It prompts you for the password. This will take a few seconds to complete. As you can see, there are various packages being downloaded from its repositories. Okay, once this is done, next we need to set up SSH. SSH stands for Secure Shell, and it is basically a program to log into another computer over a network to execute commands in a remote machine and also to move files from one machine to another. It provides strong authentication and secure communications over insecure channels. So now we will install OpenSSH by typing the below command. Type yes for the prompt. So this command actually downloads and installs the OpenSSH server and the client as well. So let us wait for the command to run successfully. Okay, now we are done. And now that SSH is set up, I can also connect to this Linux virtual machine from the Windows host. Now you might wonder, we are already in the desktop of the virtual machine and also have launched a terminal. So why not perform the necessary operations on the terminal instead of connecting to the virtual machine from Windows? Well, you can do this and it would work just fine. However, remember that in most environments, whether you're using Amazon Web Services or you have a Hadoop cluster in your data center itself, you will not be able to log in directly into a name node or to the client and access the terminal from the desktop. You will invariably have to use utility tools like PuTTY to connect to the nodes of your cluster. So essentially, we are doing this just so you get used to using PuTTY. But what is PuTTY? PuTTY basically allows a Windows user to securely connect to remote systems. Let's say your Linux server. This will be over the internet via Telnet and SSH protocols. Using SSH allows you to connect to remote systems via a secure shell, thereby encrypting information before it is transferred. For our class, we have a Windows operating system which has an Ubuntu Linux virtual machine configured on top of it. We will now connect to our Linux virtual machine using PuTTY. So now, in order to connect to my virtual machine using PuTTY, I need either the IP address or the host name of the virtual machine. To get the IP address of the virtual machine, type the below command. This what you see here is the IP address of my virtual machine. Now let us open PuTTY. For that, we have to double click the putty.exe application file and enter the IP address, and then hit the enter key. You will be prompted to choose to store the server's host key in the registry. So choose yes, otherwise you will get this prompt every time you connect to this virtual machine. This time we will log in as the root user. The authentication was successful, so you can see that we have now logged into our virtual machine using PuTTY as root user. Let us quickly run some basic commands to just verify. So this time whoami command gives the username as root. Let's quickly check the IP address. The IP address is the same IP address of our virtual machine. Next, since Hadoop is written in Java, we need to have Java installed on the machine. So we can do this by typing the below commands. These commands basically add a repository from where we can download the latest install files for Java. Now let us run the update command to get the latest install files from the repositories that we just added. Now once the reading of the package lists are done, we can finally run the command to install Java version 1.7. Choose yes. Hit the enter key to accept the agreement and use the left arrow key and choose yes for the license terms. This command will first download and then install Java on our virtual machine. This will take a bit of time to complete. Okay, as you can see, the download of the Java is done and it is still in the process of completing the installation. So let us give it a little bit more time. Okay, once the Java installation is done, we need to set up the Java_home variable to the path of our Java installation. Since we did not provide a path for installing Java, we need to find out where a Java was installed. So you can use the find command to find out the files that start with the name Java hyphen. So you can find out where Java was installed. So let us use the find command to do that. So note that you need to be in the root directory to do this. Alright, it does give you a list of results. Typically in this folder, if it is Java version 1.7. So let us copy the path. I'm sure we'll need it somewhere. So once we have path of our Java installation, let us update our Java_home variable. We can do this in two ways. One, by using an export command like this. Let us check if this command actually worked for us by echoing the variable. It did. However, remember that this export command will be applicable only for the session, and if you close the session and then log in later, the variable would not be updated. So to avoid this, we will simply include this export command in the .bash rc file in your home directory. But what is a bash rc file? Well, we know that Linux can have multiple shells, and shell is basically a program that takes your commands from the keyboard and gives them to the operating system to perform. Bash, which stands for born again shell, is the most commonly used shell, and the .bash rc file is typically used to change prompts, set environment variables, and define shell procedures. So the .bash rc file is read when a new terminal window is launched or the shell is invoked the first time. Now let us edit this file, which is in the home directory. So let us go to the home directory of the current user. Let us list the files in the directory by typing the command ls. I do not find anything here. The reason for this is that the bash rc file is basically a dot file, and the dot files are actually hidden. So to view the hidden files, you should use the command ls-a. So as you can see, you can see the .bash rc file here. So let us edit the .bash rc file using the vi editor. Scroll all the way to the down and paste the command export . Once you have done this, save and exit using the escape and :wq commands. Now let us quickly execute the file to reflect the changes we made. For that, we use the source command. Source is basically a bash shell built-in command that executes the content of the file passed to it as an argument in the current shell. So in our case it is the .bashrc file, and with that we have successfully installed Java and also updated our java_home variable. So you need to edit the .bashrc file of your users who will be logging into the virtual machine using PuTTY. So with this we come to the end of the first part of videos on setting up Hadoop. In the next couple of videos we will talk in more detail about adding dedicated users to manage Hadoop, setting up SSH for Hadoop, etc. Thank you for watching and stay tuned.